Hi guys, so in this video I'm going to go over some of the questions, but not all of them, for the iDay assignment on circles and angles. So I'm going to try to cover all of the different theorems that we did in class and show you which problems use which theorems. So let's begin with the first two problems. You need to look at the directions and notice that here it says to assume that the lines which appear tangent are actually tangent, which in this case, for problem number 2, we see that these two lines appear to be tangent to a circle. So I'm going to assume that these two lines are tangent to this circle. Remember, tangent means that it touches the circle at a single point. Well, the first problem, let's actually begin with that one. This first problem, it's an example of the outside angle theorem. If you notice, for the outside angle theorem, we have the angle outside, and we have an outer arc and a inner arc. So, and here's the formula. The angle outside is equals to 1/2 the outer angle minus the inner angle. So that's the formula that I want to use to solve for this problem. Again, you see the angle outside is 40. So the formula says that the angle outside, which is 40, is equals to 1/2 times the outer angle, which is 129, minus the inner angle. Sorry for the question mark, let me make it x instead of question mark. So minus x. Again, outer minus inner. So this is the formula. I just recreated the formula, but instead of using the symbols for angles, I use their actual measurements. The angle outside equals to 1/2 the outer minus the inner arc. So let's solve for x. To leave x by itself, first let me get rid of that 1/2 by multiplying by 2. That way the 2 on the bottom and the 2 cancel out, leaving me with 80 equals 129 minus x. Then to leave x by itself, let me subtract 129 from both sides. So these go away, so minus 129 plus 80, or 80 minus 129 equals minus 49. So minus 49 equals minus x. Now when you have negatives on both sides, they actually cancel out, so they become, both of them become positive. So x equals 49. So that's the value of this arc. It's 49 degrees. And that's it. That's the solution for the first one. Now the second one. Alright, let's see what theorem is the second one. We have the tangent lines. So we're talking about the circumscribed angle theorem. So we want to look at this one. Now you will notice that the circumscribed angle theorem, there's actually two equations. The reason why there's two, it's because we have this angle here, which is angle 2, and we also have this arc over here, which is arc AB. And because this angle is a central angle, this angle right here measures the same as this arc. So if this angle measures 30, then the arc also measures 30. So I can make two equations, one of them using the angle and the other one using the arc. The angle outside is equals to 180 minus the angle, or the angle outside is equals to 180 minus the arc. And that's it. So which equation do you use? It depends. If you're given the angle, use the equation using the angle. If you're given the arc, use the equation using the arc. In this problem, I'm being given the arc, so I want to use the second equation, which uses the arc. Okay, in this case, my x is going to be the arc, because that's the value that I'm missing. So x is the arc. The angle outside, let's see, the angle outside is 55. So 55 is equals to 180 minus the arc. which is x. So let's leave this x all by itself. So let me subtract 180 from both sides. So this goes away. So I'm left with 55 minus 180. That leaves me with minus 125 equals minus x. Same thing, let's get rid of the negative, so x equals 125. So that's the value of this arc, 125. And that's it. So that's question 2. Questions 1 and 2, outside angle and in circumscribed angle theorem. Now, these two problems, if you notice, for problems 3 and 4, we're talking about central angles. One thing to remember about central angles, as I already mentioned, is that central angles, the angle inside is equals to the arc. So let me show you an example. In this example, you see the angle inside is 97 degrees. So the question is, what's the measurement of this arc? Well, because the arc and the angles are the same, this arc, or this x, would be 97 as well. So if this measures 97, then this also measures 97. Now, if you notice, for problems 3 and 5, all of these are central angles. As you can see, this angle right here is 119. Well, that means the arc from here to here, it's also 119. You see this arc is 110. Well, that means that this angle right here is also 110. This angle right here is 50, and this angle right here is 36. Again, because they are given. The question is how much is, well, actually it's asking me to find out the measurement of NKM. Well, here's the thing. For NKM, we're talking about points N, point K, and point M. So the question is, what's this arc? How is it going to look like? You have to go in the following order. You need to go from N to K and then to M in that order. Alright, you cannot skip and you cannot touch one and then the other. It has to go from N to K to M. So from N, I cannot come downwards. If I go downwards, I'll be touching M. And M is the third one. So from N, I actually want to come around this way to get to K. Alright, and then I can go to M. So technically the question is, what's the measurement of this whole arc, this whole green arc? Well, that's pretty easy. All the way around is 360. All the way around the whole circle is 360. Well, 360 minus this piece. So technically I get 360 minus 36. And 360 minus 36 gives me 324. So 324, that's this whole green arc. Alright, so the measurement of arc NKM is 324 degrees. And that's it, that's question 3. I'm not going to do question 4, but a few things to remember is that this angle right here and this angle right here, these are vertical angles. Also remember that on a straight line, the angles must add up to 180. You already know this angle is 64 and this angle right here is 66. So if you can find out the measurement of this angle, then you can find the measurement of this one. So it's that easy. Alright, for questions 5 and 6, when you have the angles that go all the way to the one end of the circle, like you see it bounce back, this is called an inscribed angle. If you look at number 6, we actually have a lot of inscribed angles right here. All of these are inscribed angles. We found them inside of the circle, but they're like bouncing off of the edge of the circle. So for the inscribed angles, I want to use the inscribed angle theorem. We have two types of inscribed angle theorems. We have this inscribed angle theorem, where the angle occurs somewhere inside of the circle, and then we also have this other inscribed angle theorem, which, guys, as you can see, this is the one that I want to use. This is the one inscribed angle theorem that I want to use. Pretty easy, pretty simple. It's the angle formed inside of the circle is equals to 1/2 of the arc being made by that angle. Alright, so if I know the arc, then the angle is going to be half of that arc. The thing is, I don't know this arc. It's not given to me. Okay, that's a little tough, but I'm given these two arcs over here. I know the length of this arc, and I also know the length of this arc. Now I do know something. I know that a circle all the way around is 360. So I can find this out by adding these two first. These two together, let's see, 115 plus 153 gives me 268. So these two together are 168. Well, let's subtract 360 from 268. I'm left with, well, subtract, I'm left with 92. That means that this arc right here measures 92 degrees. And that should make sense. You can double check on your phone that these three angles, again, all the way around the circle, it's supposed to add up to 360. So let's see, 115 plus 153 plus 92. Does that add up to 360? Definitely it does. So if I know this arc is 92, well, the angle has to be half of this arc. Well, half of 92 is going to be 46. So 46 is this angle inside. This angle inside measures 46 degrees. That's it. So it's pretty handy to know the arc that's being made by this angle. Okay, if you know the arc being made by the angle, then you can just cut the arc in half, and that's the answer. Now, if you look at problem 6, I'm not going to do it, but again, we want to know the measurement of the arc made by that angle. If I want to know this angle right here, it would be handy if I knew the measurement of the arc made by that angle. The arc made by that angle, it's all of this thing in green. Well, look at that. We actually know this arc over here. We know this arc over here. So I can take these two together. And this one, the three of them are supposed to add up to 360. It's the same process. I'm not going to do it, but there you go. Let's go to the back of the page. Alright, so right here I have problem 7. I'm just going to explain how to do it, but I'm not actually going to do it, maybe. But let's see. So in here, all of these angles are central angles. Now, if you notice, all of the angles are given. I'm giving this angle. Okay, I'm giving this angle, this one, this one, this. I'm giving all of the angles all the way around. So all of these angles together are supposed to add up to 360. So the equation should be, well, all of the three added together. So 37 plus 12x minus 5, that's this second one, plus the third one, which is minus 2x plus 12, minus 2x, minus 2 plus 12. Then the next one, which is plus 4x minus 5. Then plus, I don't have space, 15 plus 4x equals 360 all the way around. So once the equation is made, then you can just solve for x, leave x by itself. Yeah, just combine like terms and leave x by itself, find the value of x. That's pretty much how you do this one. You know what, let me just do it. So combining like terms, that means I need to combine 37 minus 5, minus 2, 12, minus 5, and 15. So those are the terms that don't have x. 37 plus 15 plus, let me just use my phone. So we have 37 plus, well, minus 5 plus 12 minus 5 plus 15. So I get 54 with no x's. Now with x's I get 12x and 4x and 4x. So 12x, that's 12 plus 4 plus 4. So I get 20x. And remember, on the right side we still have 360. So let's leave x by itself. So let's subtract 54 from both sides. So I get 20x equals 360 minus 54, and I get 306. Then to leave x by itself, I'm going to divide both sides by 20. So x equals 306 divided by 20, which is 15.3. Now this is the value of x. You are being asked to find the measurement of angle DGC. So we're looking for this angle. Well, we already know the value of x, so we can just take the equation, which is 15 plus 4 times x, and I already know x is 15.3, so I get 76.2. So this angle is 76.2. Need help? Okay, on to the next problem. Problems numbers 9 and 10. Problems 9 and 10, again, the theorems that we're going to be using, it's the inscribed angle theorem. Like we did for... Okay, so in this example we did the inscribed angle theorem. This is what we used. Now remember that the angle inside is half of the arc. The arc is twice the angle. So right here, I just want to make use of that equation. The angle inside, 15x plus 3, is equals to 1/2 the arc, 32x minus 4. Now there are several ways to solve for this. You can either multiply both sides by 2 to get rid of this 1/2, or you can distribute this 1/2 to both of these. I'm actually going to distribute the 1/2. So on the left side, I'll have 15x plus 3, and on the right side, when I multiply by 1/2, everything's just halved. So I'll get 16x minus 2. Then to leave x by itself, I can just subtract 16x. Actually, let me subtract 15x. It doesn't really matter which one you do. Subtract 15x. So on this side, that goes away. So 3 equals x minus 2. And finally, to leave x by itself, just add 2 to both sides. So x equals 5. Now this is the value of x. It's asking me to find the measurement of arc KL. It's asking me for this arc. Well, pretty simple. I already know the value. Of x. So I want to put this thing, but just replace x by 5. So 32 times 5 minus 4. So my arc measures 156 degrees. This arc is 156 degrees. And that's it. And actually, if you want to double check that this angle is half of this one, you can use the same, well, you can use the equation 15 times, again x is 5, parenthesis, then plus 3. You can see 78 must be half of 156. Well, let's see, 156 divided by 2, it's 78. Perfect. So it worked, and it's the same process for this problem 10. Problems 11 and 12. This is an outside angle theorem. This is the tangent intercepted chord theorem, outside angle theorem, and inside angle theorem. I'm going to do 11, 12, and 14. So I'm going to go through it pretty fast. I'm going to use the equation for this one. The angle outside sets x is equals to 1/2 the outer angle, 160, minus the inner angle. When there's more than two terms, I like to put the terms in parentheses, especially if there's a minus. So 6 plus 10x, then close the parentheses for this one, and then you need to close another parenthesis for the outer ones. So let's simplify this. First of all, let me simplify the thing inside of this parentheses, because this negative actually has to be distributed to these two terms. So I'll get 6x equals 1/2 160 minus 6 minus 10x, close parentheses. Alright, once you distribute the negative, you don't need the inside parentheses anymore. Now let's actually multiply everything by 1/2. So everything inside will be halved. So I will get I'll get 80 minus 3 minus 5x. And actually the 80 and the minus 3 become 77 minus 5x. Let's take all the x's to one side, so let's add 5x to both sides. So I'll get 11x equals 77. So x equals 7 after dividing both sides by 11, right? Because 77 divided by 11, it's 7. So that's the value of x. And then I'm being asked to find angle STV. STV. So I'm looking for this angle. Well, the angle is just 6 times x. Well, x is 7, so angle is 6 times 7. That means this angle is 6 times 7, it's 42 degrees. And that's it. 12. 12 is the tangent intersected chord theorem. So it means this angle is half of this arc. So the angle 63x plus 1 equals half of the arc. The arc is 127x plus 1. Now in this problem, I'm actually not going to distribute the 1/2, because if I distribute it, I'm gonna get like 0.5 here, point something something 5, and then again 1/2 times 1, it'll just give me 0.5. So what I'm going to do is actually I'm going to multiply both sides by 5. This side I'm going to not by 5, sorry, by 2. So the 1/2 and the 2 will cancel out. And then on this side, I also need to multiply by 2. Now here's the thing, if you have more than one term on the left side and you are multiplying both sides by 2, this whole thing has to be multiplied by 2. So the 2 has to be distributed to this whole thing. So it'll become 126x plus 2 equals 127x plus 1. Let's leave x by itself. So let me subtract 126x from both sides. So I'll be left with 2 equals 127x minus 126x leaves me with only 1x plus 1. And then to leave x by itself, let's just subtract 1 to both sides. So x equals 1. So that's it. It's asking me to find the measurement of arc JMK. You gotta be careful for this problem, because we're looking for this arc over here. It seems a little tricky. Well, I need to know the length of this arc on this side. Again, that's pretty easy to find. Let's just use my calculator. I know x is 1, so I'll get 127 times 1, which is 127, and then plus 1. So this arc over here measures 128 degrees. This arc is 128. Well, if that arc is 128 and we need 360 to go all the way around, well, the remaining of the circle has to be whatever we need to get to 360. So that's just 360 minus 128, which is 232. So this arc over here is going to be 232 degrees. And it must make sense. Well, let's see. If 232 is this arc and this other arc is 128, well, both of them together must give me 360. And they do. So that's it. That's MJMK is this one. That's your answer. And this is the answer for 11. 14, it's the inscribed angle theorem. Remember the inscribed angle theorem, I need to use this one and the 50. So inscribed angle theorem. So the inscribed angle theorem, it's right here. And pretty much, if I want to find, let's say, these angles, I need to use these arcs. If I want to find these angles, I need to use these arcs. And the formula, it's the angle that I'm looking for is equals to 1/2 the two arcs added together. So that's what I want to do here. The angle that I'm looking for, which is angle G, let's call it just angle G. Let's just call it G, is equals to 1/2 the two arcs added together, 190 plus 50. So G equals 1/2 190 plus 50, it's 240. So that means that G equals, well, half of 240 is 120. And that's it. This angle is 120 degrees. Pretty easy, pretty straightforward. That's that one. Now, the back of the page may seem a little interesting. Is this the back of it? It is. Alright, so we've got pretty easy problems here. Let's see. 15, find the measure of the arc or angle indicated. So it's asking us to find this arc over here. So these problems are just going to get a little interesting. Now here's the thing, we know all of these angles right here, this angle right there, this is an inscribed angle, so I know the angle, I know the arc because I already know the angle. So this arc, this red arc, measures twice the angle. That'll be 142 degrees. That's the red arc. Then I also know this arc here made by this angle, so that'll be the whole arc all the way here. I'm going to be overlapping the red a little, okay, just up to E. Well, I know the arc is going to be twice the angle, which is going to be 206. Now you gotta be careful here, because 140 is from F to G. That's 140. 206 is from G all the way to E. And 142 is from F, sorry, it's from F all the way to J. I mean, all the way to V. So you just got to know that. Now, here's the thing, we're looking for this one. That's pretty easy to find. It would be nice if I knew the arc from F to E. That's pretty easy to find. Let's find it. I know this part, the 140, is just this part of the green. So if I take 140 from 206, I'll be left with this part of the green. So 206 minus 140 gives me 66. So pretty much again, 140 is this part. This part is 140. If I get rid of 140 from 206, I'll be left with this. So that is 66. Right now, that's 66. Well, I know this whole thing from here, from F all the way to V, is 142. Well, if I take away 66 from 42, I'll be left with EV. So 142 minus 66 gives me 76. This angle measures 76 degrees. There you go. So that's the arc from E to V. 76 degrees. And that's technically what you want to do for these problems. They're just a little messy, but again, use the information that you have. Let's say for this one, you know this angle right here. Well, you know this arc over here. That's the only hint that I'm gonna give you. So yep, it's gonna be fun. 17, it's find the measurement of the arc or central angle indicated. I'm not gonna do this one. It's asking you to find measurement of angle I, L, J. So remember, you go from I to L to J. So you're looking for the angle all the way around. Well, the arc all the way around. But that's easy. Again, these are central angles, so this angle and this arc must be the same. Alright, this arc is this arc is this arc is this arc is this. Just add them up. That's just what you have to do. Just add them up, and that's the solution. Now I'll let you guys try 18. 19, I'm not gonna do 19. I pretty much did 14, which is the same thing as 19. I'm not gonna do 21. It's similar to this. I'll set it up. Actually, I'll set up these two. Remember the angle outside. This is an outside angle theorem, so the angle outside is equals to 1/2 the outer, 174. Then we make this one x minus the inner. There you go. Solve for x. Find the value of x. This one, remember, to find this angle, which is also this one, you need to use the angles, the arcs. So this angle 106 is equals to 1/2 these two angles. Add it together plus x. Remember, inscribed angle theorem, you add them. Outside angle theorem, you subtract them. Okay, that's why this one's adding and this one's subtracting. You just have to know the formulas. Alright. This one, I don't even have to try this angle. I already know this arc is 120, so the angle is half of the arc because it's an inscribed angle theorem. So it's going to be 110. That's the answer. This angle is given to me, it's 60, and the arc, that's what I'm looking for. Again, it's twice the arc, it's twice the angle, it's 120. That was very easy. Alright, now let's move on to the back page. The back page, now the back page, it's a little, here's the thing, don't do 24 and 23, also skips numbers 25 and 26. These problems are very tedious. You need to use systems of equations, and I don't want you to use that. Now for the rest of these problems, 27 and 28, they're pretty easy. Again, this angle right here, it's the angle inside, and 8x minus it's the arc. So I'm going to use this arc and this arc. So 7x minus 2, that's the angle inside, is equals to 1/2 these two arcs added together. It's the inscribed angle theorem. So 7x minus 10 plus 7x minus 2. solve for x. Yeah, just solve for x. Whatever you get, plug it in for x here, and that's it. This one, to set it up, well, remember the angle is half of the arc, so the angle 3x plus 32, it's even pointing you there, it's the angle, is equals to 1/2 the arc, and the arc is 10x plus 20. And there you go. Solve for x. Leave x by itself. You're looking for arc AB. So once you find x, just plug it in for x. So 10 times whatever value you get plus 20. And that's going to be your arc. Now, 29 and 30, I'm not going to ask you to do these ones. I actually took a look at these before actually attempting them. And if you look at this problem here, this is a straight line. So if this is 30, then this one has to be 50, because on half a circle, I'm supposed to get 180 degrees. Now this angle and this angle, they are actually vertical angles. So if this is 50, then this one's also 50 degrees. Now this plus this plus this, they are half a circle, so both the three of them together have to add up to 180. So it's going to be the 5x plus the 10x minus 5 plus the 50 to be equals to 180, because it's half the circle. Solve for x, and then you're looking for UVS. You're looking for this angle right here in the middle. Find the value of x and plug it in. 30, I haven't even looked at it, but as I can see, it's again the same concept. You can see there. So this plus this one has to be equals to 180. Yeah, this one is going to be a little more tricky, but let's see. Also, this plus this could be 180. These two angles are the same. Oh, look. If this angle and this angle are the same, then this angle and these two together are the same. So there you go. Technically 9x plus 13 is equals to these two together. 4x plus 21 plus 47. And there you go. Solve for x. Yeah, again, vertical angles, they are like this. If these two are the same, then these two are the same. Technically, that's what we got here when I made those two lines. And that's it. The whole thing is just algebra. It's just leaving x by itself and then just plugging it in. But that's how you do it. I'm not going to do all of the work. Algebra should be something you should know by now. But that's it. That's the video.